Do you see my whiteboard or not yet?
Yes, we see it.
Yes.
Excellent. We start. Hold on 1 minute. No? 2 o'clock. Okay, look. The question 12, I remember we are doing to the 11, no? The question 12 is super easy. It's compute that determinant. 1, 1, -2, -2 again, 4, -1, -3, and 5, 5. Okay, I want to do using 3 different ways. The first way is the traditional way que the majority of the students memorize, que is expand using any row, any column, whatever, but I want to using the row 1 because there are no specific reason to change that. Then you apply the cofactor formula, no? You copy the entry, que es 1, 1. That one is this. Multiplication by 1 minor determinant. Well, actually it's cofactor, pero the cofactor 1, 1, 2 is equal to minor 1, 2. So it's the same sign, no problem. The only difference between cofactor and minor is the sign, no? Entonces now we have 4, -1, 5, 5, no? Because mentally you delete the row 1 and column 1 and stay alive this number, no? Now for the second entry, okay, 1 again, by coincidence you put -1. Remember the cofactor, I make a mistake here. Hello, I'm crazy. This is 1, 1. Cofactor 1, 1. Row 1, column 1 is equal to -1, 1, 1. Hello, what the hell? 1, 1. Sorry. Entonces now cofactor 1, 2 is -1, 2. That is the reason there's negative here, right? You know, there are many ways to memorize this information. Now multiplication by the minor, que the minor is -2, -1, -3, and 5. Because I delete mentally the row 1 and the column 2. Just stay -2, -1, -3, and 5. Cool. Finally, -2, that's the entry that we continue when you navigate on the row 1, no? This is -2. The negative reason is not by the cofactor, because the cofactor 1, 3 is equal positive minus 1, 3, no? It's the same sign. Remember, there are many ways to memorize this. You memorize plus, minus, as is sequentially, or another possibility is you believe it is a -1 raised to the sum of the subgroup 1 plus 1 is 2. And it's a -1, 1 plus 2 is 3, and 1 plus 3 is 4. The even guys, 2 or 4 and so on, are +1. That's the reason it stays positive. However, the odd exponent is -1. This is the reason. And the minor associated with this idea is a -2, 4, -3, and 5. Everyone follow me so far or no? Some question? One part that you don't understand very well? Any extra explanation? Cool. Okay, so now we focus on the solution of this easy determinant 2 by 2. You multiply this, no change the sign, and you multiply this, and yes, change the sign. So we have actually 1, you know, 1 is invisible, you know. You open the parenthesis, I like to open the parenthesis and perform a multiplication. 4 times 5, 20, and 5 times -1, of course, -5, but extra negative is +5. Minus -1, que is invisible. In this case, you multiply is -10, que es the multiplication, -2 and 5. And when you multiply in that direction, the sign stays the same, but when you multiply in that direction, you include extra, -1. Those three negative together is negative. So it's negative, negative, -3. -2, parenthesis again. I open the parenthesis for focusing and the computation of the determinant 2 by 2, no? This is plus, no change the sign. This is minus, yes, change the sign. Actually, we have -10, but the corresponding sign, no change the sign, is -10, because -2 times +5 is -10, and -3 times +4 is -12, and extra negative is 12, +12. We almost finished. This is 25. This is -13, but we have a minus and there's a +13. We have here 2 positive, but we're going to multiply by -2 outside and -4. Now you have 34. 34 because 25 plus 13 is 30, 38. No? 38 minus 4 is 34. That's the answer. This idea is correct? Everyone follow me or no?
Yes.
I don't know if you like, I want to explain another way. I consider it important when you have, for example, this is everyone doing like that. When you have 3 by 3. But if you have 4 by 4 or 5 by 5, so no, it's too long using the cofactor formula. And we need to do another thing. Let me try. I copy again my question. I want to solving in different way. And you see the beauty of this. I apply the property of the determinant. The determinant have a lot of property, but one super fantastic property is when you apply row operations or column operations on the determinant, unbelievable. You adding, subtracting, multiply by factor, unbelievable. The determinant value stay the same. Unbelievable. It's science fiction for me. So I propose you one idea. Look, you perform the following. You multiply by 2 factors, the row 1 plus the row 2, and storage in row 2. What is my intention? Well, my intention is somehow make 0 here, in that position, 0. Entonces now es obvio que the number is 2, but the opposite sign is positive 2, no? Entonces now I copy the row 1, exactly the same, I don't change. I copy the row 3, exactly the same, because I don't touch. However, when you are doing the operation, this is 0, no? Es obvio que es 0, no? 2 times 1 is 2. Remember 2, 2, and 2, no? 3, 2 we have. Multiplication by the corresponding number in the row 1, que es the pivot. 1, 1 is a coincidence, and -2. Plus the row 2, que es -2. Plus 4. Plus -1. So the answer is 0 here. That's 0. Nice. Then the other answer is 6, I guess, or no? 6. Because 2 times 1 is 2, plus 4 is 6. We have here -4, and -1 is -5. So we have 6 and -5. We almost finished, because one more transformation, one more row operation maybe is 3 times R1 plus R3 storage in R3. I now try to do my best in order to get 0 here, right? 0 here. Okay, but what should I do? Well, I copy the row 1 exactly the same. I don't touch anymore. 0, 6, and -5. I don't touch one. Actually, the one I using, but I never change. Only change the row 3. And when you multiply 3 times 1, it's positive 3. Minus 3 is 0. This is minus 1. Now, this is 8 and negative 1. Let me check it. I copy directly from my paper, but I want to verify, no? Entonces, 3 times 1 is 3, plus 5 is 8. And 3 times minus 2 is minus 6. Minus 6 plus 5 is 1. It's negative 1. So, do you follow me, guy? Yes or no?
Yes, we follow.
Okay, now, I am guarantee you 100%. When you compute this new determinant, it's exactly the same 34. It equals the original. But in this case, I using the cofactor formula one more time, pero using the column 1. Remember, in the determinant, it's nice. We can use a row or column. In the matrix, no. In the matrix, we use it always row, never column. Because it's different meaning. The row and the matrix is the equation, no? And the column is the variable. Determinant, no. Determinant is a mathematical object. Okay, you can associate with the system, but it doesn't matter what is the row, what is the column, what is the equation, what is the unknown. Entonces now, you, in order to apply one more time this formula que contain 3 cofactors, 1, 2, 3, 1, 2, 3. We have only one cofactor, que es the cofactor 1, 1, que es 1, que by the way is positive, and the minor associated is 6, negative 5, 8, and negative 1. Ready to apply the formula or the algorithm for the 2 by 2. You multiply this guy with the same sign, and you multiply this guy and the opposite sign. 1 is invisible. You have minus 6 plus, because double minus, plus 40. And 40 minus 6 is 34. Same answer. What way you prefer? The first way or the second?
The first way.
Okay, cool. It's more systematic, I understand. More, mechanical. The other is more artificially because you need to predict the column operation or the row operation. In this case, sorry, I am talking about, wow, I'm crazy. This is column, no? No, error. I am right. Sorry. Error. No column. The column was the last one. Okay, however, 13 is the same idea. But in the 13, I anticipate this idea because our determinant, I take advantage that we have 2 0 in the first row. What should I do? You expand using the row 2 or the row 3 or the column 1 or the column 2 or the column 3 or the row 1. So because the row 1, no? Because I take advantage that we have 0. Now, the only cofactor is 3 times the cofactor gets formed by when you delete this mentally, this and this, delete. It's a state 6, 4, 9, 8. Now multiplication. This and this with the same sign, no change the sign, this and this, yes, change the sign. So don't forget that 3 times, parentheses, 48 minus 36. 6 times 8, 48. 9 times 4 is 36, but negative. When you subtract, it's 12. And when you multiplication, now 36. Boom, final. That question, guys. Well, you can use GeoGebra, but for checking, I want to see the computation by hand. And this. And the Kramer rule, no, because it's too low. But in the computation, only one single determinant. Yeah, of course, by hand. Okay, so do you understand 13 very well or no?
Yeah.
Okay, now 14. 14 you can expand, or you can, but if you realize.
Excuse me. Sorry, sir, I wasn't able to enter class yesterday. Well, sorry, not yesterday, Monday.
Okay, you watching the video on YouTube?
Yeah.
No problem.
Okay.
It's not equivalent, you know, because you cannot ask me something that you don't understand, but it's a one possibility. Okay, it's a yeah.
Okay.
This is the beauty. This is the beauty of the online class. Okay, so now let's focus on 14. 14, you see, wow, I see something interesting. I saw that the row 1 is equal to row 3. Do you see or no? This row and this row is the same. And what happens when the row is the same or the column is the same in one determinant? What happened? Do you remember? Somebody remember? No idea? The answer is 0. When you have two rows or two columns equal. But not necessarily equal. It is proportional. Look, suppose you have 1, 2, 3, 2, 5, 5. And you, for example, multiplication by 2 or by 3, by 2. The last row. It's 2, 4, 6. No? This is also 0. Because you can discover the common factor gets 2 and you factor out. You factor out these 2 here. This becomes like a 1. This becomes like a 2. And this becomes like a 3. No? Also, I remember the property can say in one determinant you have two equal rows. So this guy is 0. It's obvious that 2 times 0 is 0. So not necessarily equal. Equal or proportional. The proportional means when you, for example, proportional means, well, okay, is their common factor, no? Suppose 2, 4, 6, no? If you divide 2 divided by 1, 4 divided by 2, 6 divided by 3, so I take this number as this number, and 1, 2, 3 as this number. See, the answer is the same, get 2, they are proportional. They are proportional, as they say in your name. Therefore, get the common factor to your factor. So not necessarily equal to row or to column. Si es proportional, is also 0. It's a property, fantastic property of the determinant. Any question, guys? Do you follow me? Sure. Okay. I want to erase the board. Let's move on to the long part. But it doesn't matter. Let me try to do my best. Look, the question 15. This question 15, we can solve the system, but I need to say the test specification is using Kramer rule. Suppose you're solving using reducer row echelon form is possible, or inverse symmetry is possible. You have no credit because the question specification Kramer rule. I know the Kramer rule is long, sorry, but there's only one question like that. Okay. So what is the system? The system is giving us 5x plus 9z equal 52. This is my first equation. The second is minus 6x plus 3y minus az equal minus 42. This is my equation number 2. And the last equation is 2x minus 6y, no z is missing, equal negative 14. And this is equation number 3. This is my system that I need to solve using Kramer rule. Okay? Let's do it in the organization. the organization is. You compute one determinant that is called capital D, that is formed only by the matrix of coefficients. So remember, determinant always we can using or we can apply for solving system, linear system of equation. Of course, determinant is applied for the square matrix, 3 by 3, 2 by 2, 4 by 4. No rectangle. So the idea that we have behind, que aumente, no, it's different. Look, so you form the coefficient get 5, 0, 9, -6, 3, -8, okay, 2, -6, 0. And now we computed this, and this case allow, not by hand, guys. You using GeoGebra. You let me know after, when I finish the organization, so you believe we need to see one more time the procedure in GeoGebra. So you believe no, entonces we save time, because I know the answer. And who is dx? It's the same determinant, D, but you replace the column of the x, guess this. The column of the y is this, and the column of C for the right hand side number, get 52, -42, and -14. This is the new x and dx, and the rest stays the same. Okay, I compute that. Now dy is exactly the same, but now you replace the column of the x, is this. This column you replace by the right hand side, is this. Okay. Is 5, 5, -6, and 2 stay the same. Now 52 in the middle, -42, and -14. And the third column stays. Okay, you only replace the corresponding column according to the variable, si es x, es y, or es z, by the right hand side. Okay, so the last is 5, -6, 2, 0, 3, -6, and 52, -42, and -40. Okay, and we have 4 values. Guys, you consider, you be honesty. You consider que es necesario que I explain again the procedure in GeoGebra or no? Opinion. I need to hear opinion. Remember, this is for you. The review for you. I am doing this job. I am doing this to explain the most better I can do that, and you get the higher score in your test. No? Opinion, guy. Jamie, Allison, Jose Ardilla, Daniel, Michael, Karim, Leila. I suppose guest user. I suppose guess Mr. Petty, no? Mr. Petty, you are guest user, no? You never have credentials. Yes. Yeah.
I don't. I saw someone change their name. I don't know how to do that.
Well, one day you learn to type it. Jocelyn, David, opinion, guy. I repeat again the process or not necessary? Jose, you want to say something?
Yeah, go ahead and do it.
Go ahead, do it. Okay. Okay. I understand now. Okay, let me try to open my GeoGebra. I have the GeoGebra. Well, I frequently work in calculus 3 with the GeoGebra. Entonces I need, y en trigonometric, when they explain trigonometric, I use also GeoGebra. Okay, let me try to share the screen with you, and immediately I want to explain step by step. Switching to GeoGebra Classic. Okay. You see now? Cool?
Yeah, we see it.
Okay, cool. Now you press this 3-line horizontal line. Yeah, you know, it's to get the menu. And you have different possibilities to save something. But you go to the view because GeoGebra have different windows for different applications. Okay, the window that we are using in this part are CAS, no graphic, I don't want to do any graph, and spreadsheet. Okay, you click outside, all right, clear outside, clear outside, clear outside, clear outside, and you enlarge the window depending the way you use comfortable for you. Okay, now in the spreadsheet I type in the matrix editor. I type in any place, guys. File. Let me know say make a mistake. I try to don't make a mistake, but I'm human. Okay. So you enter. -6.
Supposed to be 509.
509. Oh yeah. 09. 09. All right. Thank you. -63. -8. To navigate horizontally, I type in my keyboard tab. Si I want to change the line, you press enter. Entonces esto. This is my array of number to determine capital D. Just in case, because I want to use I copy here one column, and doesn't matter if it's beside or too far. The right hand side number get 52 positive, enter, -42, enter, and -14. To format this, I want to copy, you select this range, you copy and paste 4 times, okay? Because the original was using for D, 2 space. The second is using for the Y, 2 space. I try to make symmetric. Okay, listen, you replace the right hand side, copy again for the first column. I copy here, yeah, I click paste. Cool. The second now is Y. Paste and C page. Okay, ready to format 4 determinant. You select the first, you create the matrix. If you want rename, this is totally optional. I call capital D. Let me try to finish the edition, and finally, after when they have the matrix, I perform the computation of the variable. So now I select the second, create a matrix. Guys, it's obvious that you have to practice by yourself. You open your GeoGebra Classic. There another software to do this, VX. I try, but for example, Symbol Lab, it's possible to use it, but I don't like because you have too many advertising. No, I do not consider professional. GeoGebra is professional. Okay, now select this, create a matrix. Sure, create a matrix. I rename dy. And finally, the last, create the matrix, DZ, rename DZ. Then, finish the edition, now computation. Computation is in CAS, that window, the window in the middle, not necessarily in the middle. When you open that, depending on the order, maybe that window is located in different, in the middle, on the left, or depending on the order, but that is not important. Now you could put determine. The command function is determine. Determinant of D. Determinant of D is 30. Is 30. Likewise, determinant now. I don't finish to type in the word. However, you see, determinant dx is 150. Therefore, the x value of the variable is according to the formula for the Kramer rule, is the determinant dx division, I put outside the parenthesis, division determinant of D. Does it perform both? And when you press enter, the answer is 5. The x is equal to 5. Let's do it y and z using that formula. So y would be equal determinant of dy divided by, outside I copy division in my keyboard, cool, determinant, okay, of D. It's a formula of the Kramer. So presented, bang, F4, because actually, si you compare separately, determinant y is 120 divided by 30, F4. Okay, and what about this z? Z is equal, again, determinant of dz divided by, I press enter, no enter, no, it's division, hello, division, determinant, no, I misspelling, DE, determinant of D is, enter now, F3. I suppose the determinant Z is 90 divided by 30 is 3. And the solution of our system is the triple order 5, 4, 3, que es the option A. Any question, guys? Do you understand very well? I know it's too long, but it's easy. And you can do using the song. Cool? No problem. Everyone follow me. Whiteboard. You see my whiteboard? The answer was in this example. Yeah, the answer in this example was 30, 150, 120, and 90. And when you apply the formula for the Kramer rule is x is equal dx divided by d. Is 150 divided by 30 F5. Y is equal dy over d is 120 divided by 30 is 4. And z is dz over d, and dc is 90 divided by 30 is 3. Therefore, the solution for the my system is x comma y comma z, and numerically is 5 comma 4 comma 3, and the handout is the option. No problema, guys. You understand very well or no?
It's clear.
It's clear.
Yes, it's understandable.
What are the typical mistakes? The typical mistake in the test is that some students, que maybe do not assist to the review, I don't know, is doing this problem not using Kramer rule, using echelon. If this is correct, you get the same answer. No? That's the beauty. However, no, this is not the assignment. No? The assignment is using Kramer.
So,
Go ahead.
On the test, can we write it exactly like this? Or
Well, not necessarily, mister. You make a screenshot of the GeoGebra and you attach to the test.
So we send you a screenshot of every question that requires.
Yeah. Using your imagination. You are a professional, or at least you want to convert to be in the future professional. So using your imagination, pero imagination que I understand. ¿No? Porque some students send me a test que es a mess. I don't understand because I supposed to copy for another guys. Entonces con copy y don't understand, don't copy right, copy wrong. Y ahí immediately detect que you don't know anything. Pero it's okay. One possibility is in the mechanical part. Bueno, you set out the matrix. And, o sea, this is paper. This is the word of paper. Everything is paper. That part is also paper. But the computation of this is to go from this to this number is a software. Clear? Clear or no? Question 16 is very, very similar. I don't want, of course, to repeat again the process. 16, no? 16, 1, 6? Yeah, 16. 16 is x minus y plus 4z equal 4. Equation 1. 2x plus 1z, so y is missing, equals 0, equation 2, and minus x plus y minus 4z equal negative 8. Equation 3. Do you see something weird in this system to predict the solution? What happened to equation 1 and equation 3? No idea, right? Intuition is important in the life. Suppose that you take the equation 3. I don't want to do it this way, of course, but I try to dedicate at least 5 seconds to visualize the system, no? In order to before to write anything. If you take the equation 3, and multiply by negative 1, this equation 3. Because we have x minus y minus 4c equal positive 8. And this is the thing, equation 3. And please compare this equation and this equation. Do you see contradiction? But I make a mistake, no? Yeah, I make a mistake. But this is positive, no? Sorry, make a mistake. This is plus, no? This is minus, this is plus. What do you say, Mister? I don't hear you.
It's the same thing.
No, it's not the same. It's the same, the left-hand side. For the left-hand side, any expression, whatever, is equal 4, is the same, exactly you say, is equal 8. Does this is true or false? Because any expression is equal 4, and the same twin brother expression is equal 8. Do you see contradiction? Do you see or no? Everyone saw contradiction? Entonces now
Yeah,
what?
we did.
Entonces what do you suppose to happen when you try to solve the system and you see contradiction? It's because remember we have three possibilities of the solution for the system. No, unique solution, only one, good, infinity many solution, or no solution. What do you think happened in this case when you see contradiction? Remember in the chapter 2, when you solve the system and you get 1 equal to, it's a contradiction, no? It's false, no? What means that?
No solution.
No solution. However, if you manipulate the system and you get 2 equal to, it's true, but we cannot solve the variable, it's because we have infinitely many solutions. But no, in this scenario, obviously contradiction indicates no solution. So this system, si you analyze no in detail, you see que have no solution. But well, I don't know. I don't know, but the professor say que I need to solve it by Kramer rule to say I respect. Okay, so I set out the D. The famous D. Okay, this is D. Dx. Dy. And dc. Okay, dx is 4, 0, minus a, replace in the column of the x, and the rest stay the same. dy, replace the column of the y, 4, 4, 0, and negative 8. And the other no, the 1, 2, negative 1, and 4, 1, negative 4. And dc is 4, 0, negative 8, 1, 2, negative 1, negative 1, 0, and 1. I suppose everyone follow me so far, right? So I go to GeoGebra. Okay, GeoGebra. I type in using my best idea, and I get this value. I get 0, I get 4, I get minus 28, and I get minus 8. Remember the formula for the Kramer rule. Is x is equal dx divided by d. Semicolon, y is equal dy divided by d. Semicolon, z is equal dc divided by d. If d is 0, you have 4 divided by 0 undefined, mistake, error. Entonces this smell not good. It's impossible to have unique solution. It's no solution. Okay, it's no solution, guys. If d is 0. And it's infinity many solutions. See, both are, see, everything is 0. Suppose que 0, 0, 0, 0. Entonces 0 divided by 0 is maybe solution. It's the terminology, so any number divided by 0 for sure is undefined. Que es equivalent error interpretation, entonces no solution. But 0 divided by 0, remember when we study rational function, que we cancel out the same factor. Entonces we continue working, no? 0 divided by 0, you see more clear when you take calculus, que es undetermined. Yeah, undetermined means que the answer of this may be a 2, maybe a 4, I don't know. So no error, pero es no determined. It's no value. So now when you see that d is 0 and the rest is just a number, like this example, there's no solution. There's no solution. Just in case, to make sure everything is okay oh no, I double checking this idea using the famous reducer row echelon. So I create in one corner of the piece of paper my augmenting matrix 1, negative 1, 4, 2, 0, 1, negative 1, 1, negative 4, separate by a vertical line, and you copy 4, 0, and minus 8. This is the augmenting matrix. Get the matrix A together with the matrix B. Now ready to apply exactly the same we are doing in the first part of this chapter, reduce the row echelon. I did that. I want to skip the GeoGebra, and you get this answer. Look, 1, 0, 1/2, bar 0, 0, 1, negative 7/2, fraction, okay? 0, and the last equation is 0, 0, 0, and 1. Remember, when you have equation, okay, 0, 0, 0, and 0, 4, 0, this equation does mean that this equation is gone because the elimination process detecting that this is linear depending of another equation. Pero no, in this case, no. In this case, you have 1 here. And so you have 1 here, it's obvious that we have contradiction, because if you translate this equation, or this row, sorry, like equation, 0x plus 0y plus 0z equal 1, and 0 times any number is 0, 0 equal 1, it's completely false, contradiction, no solution. One more time, with verification, okay, we have no solution. Cool. Cool.
Cool.
Okay, to finish the topic of the determinant, I want to raise the bar, guy. I can do that? Okay, cool.
Yeah.
To finish the topic of the determinant, I bring a couple of examples in which you can apply the properties. So one is, in this case, mandatory is by hand, because in the algebra, you can use it only just number, no letter. Entonces we have X, Y, Z, UVW, the classic example that we are doing in the lecture. 1 minus 3 minus 1. Suppose que is given this determinant and is equal, somebody computation that, and the answer is 38. Bang, is given. Because I want to using this information to compute another more complicated. Is xy c minus x u b w minus u and 1 minus 3 minus 2. No idea. Question mark. And remember the different property of the determinant. The most important, there are not many, but there are a lot of properties. But the most important is when you perform row operation or column operations, the value of the determinant stays the same. This is important. Another important is when you multiplication one row or one column by a number, of course the value of the determinant is also multiplied by the same factor. But in this case, no, because you realize, suppose you realize here, look, you focus it in this column, sorry, this column. What's going on? A ver, ¿qué pasó? There. Oh. What's going on? Maybe here in the setting. Start whiteboard. For my background, help. Start. I don't know. Okay, forget about this. Let me try to open another because I have a lot of whiteboard. Let me see another whiteboard. How many with this? Okay, let me close and open another time the application. Let me see whiteboard. There you go. This is MAC1140. But the problem is that the pen, the pen is here. There you go. Okay. Let me try again. Let's see what the pen or not. Yes. Question, do you see my whiteboard now? Yes or no?
No, we don't see it.
We don't. Okay, because it's a new one. Okay, let me try to share. Switching whiteboard, Microsoft. Now, you see?
Yes.
Cool. Okay, entonces, repetition again. One determinant que using unknown X, Y, Z, U, V, W, and numerical together, mix it together. Let's equal 38. This is giving this information. I need to compare one similar. Okay, using the same variable and not exactly the same number, different number, but there are connection, there are relationship between these. Suppose. This is the column. This is the column 1. This is the column 1. Look, this is the column 1. And this is the column 3. This is the column 3. Entonces I can see, using my imagination. Imagination is super important. Because you adding column 1 plus column 3, and you store this in the column 3, something interesting happened. Okay, let me try. Participate in the game, column 1 and column 3. Therefore, column 2 stays the same. Column 1 also stays the same because participate, pero the storage is in column 3. Entonces, when you subtracting, es obvio que x plus c minus x, wow, x is cancelled and stays z. Similar happen in the other part, is u plus w minus u, is w. And 1 plus minus 2 is minus 1. Wow! And now, this new determinant after this column operation is exactly the same of this. Entonces es equal 38. And by transitive behavior, the original is given is ugly. It's also 38 because I know very, very well that when you perform row operation or column operation on the determinant, the value of the determinant stays the same. So the procedure is always backward. So you start for the new one and try to using manipulation and imagination to look like similar or equal twin brother to the original. Not always happen que es twin brother, pero es family, very, very family. Do you understand the problem 17? Honestly. Do you understand the idea or no? Say something. What happened? What happened with the audio? We have connection with the audio? Do you hear me or no?
Yes, we could hear you.
Now, you understand this problem 17 or not?
Yes, I do.
Yes, I do. Okay. Of course, in the test, don't expect two difference. Of course, different number, but it's the same idea. I don't want to complicate too much. Just the begin, just 1 liter complication. Let me try 18. 18 is a little bit more complicated, but not too much. 18 is given one determinant, I guess, x, y, z, UBW, same thing of the previous example. No, it's not the same. I changed something in the last row. Yes, equal 146. It's given, I said that. I need to compute another, it looks like more complicated. Is x plus 3, y minus 3, c minus 9, 3u minus 1, 3b plus 1, and 3w plus 3, 1, negative 1, and negative. At least the last row is the same. And 1, negative 1, negative 3. So basically, the thing I suppose I should do is manipulation, the first and the second. I don't know exactly what is the best way to organize this. Let me try to use my imagination. I propose you perform this operation. Row 2 plus row 3, storage, and row 2. Why? Well, because if you are doing this operation, it's obvious that you are adding this row 2 and this row 3. When you are doing this, at least that part is cancelled out. Yes or no? It's no coincidence. It's a fact. Therefore, my new determinant now is x plus 3, stay the same, y minus 3, c minus 9, because we have now 3u, 3b, and 3u, and 1, negative 1, and negative 2. Everyone follow me so far? I perform this row operation in this step, and this equals sign. Everyone following?
Yes, we follow.
I keep going. Wow, look at that. I like that. I see in the second row, we have common factor 3. I factor out. Why not? It's another property. The property says when you multiply any row or any column of the one determinant or the one specific factor, in this case 3, the value of the determinant is also multiplied by the same factor. So the property talking about multiplication, but we are doing backward. We are doing factorization. So these 3 I put outside, and we have x plus 3, y minus 3, and c minus 9. And you have now u, b, w. And little by little, guys, I try to manipulate the original that I have in another very similar to the given value. Okay, so now I suppose that the last part somehow is, okay, let me try one more time, equal sign here. Okay, equal sign. Because I perform in this equal sign one row operation, yeah, row. It's all because row operation. I propose this idea. Minus 3, row 3, plus row 1, because I need to change row 1. I storage and row 1. I take the row 3 like a pivot, exactly the same I'm doing here. Row 3 is a pivot, 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 and this is also pivot. But the only thing I multiply this pivot by 3, by negative 3, sorry, plus row 2. So it's obvious that when you multiply negative 3 times 1, and negative 3 plus this expression, it's obvious that negative 3 and positive 3 is cancelled and stay x. The rest I copy UBW 1, negative 3. The only row I change is row 1. This is the storage row. Que es obvio que when you multiply by negative 3 and negative 1 together, positive 3 minus 3 is 0. So y alone, and negative 3 times negative 3 is positive 9, and positive 9 minus 9 is 0. Entonces, wow, in this moment, I can see que this is exactly the same as this. But I forgot one important thing, is this 3 I don't copy here. And this was obtained in the factorization in the second stage. So we are doing 1 stage, 2 stage, 3 stage. Stage 1, stage 2, stage 3. Pero entonces es easy, multiplication 3 times the factor, the determinant value is 146, and the multiplication is 438. Bam, finals. Like the option A again in the handout. Cool? I don't know why in any test that part the student don't understand and I'm doing wrong in the test, or don't do that. That was clear for you? Okay, I suppose you are.
Yeah, clear.
Yeah, you are good students. Okay, let's practice a little bit now. 19, 20, 21 is a algebra of the multiplication matrix and inverse matrix. Let's do it. Okay, suppose 19 is multiplication that matrix is 3, 6 minus 8 negative 9 4 minus 2 multiplication by another matrix is minus 3 8 minus 6 minus 3 7 minus 2 minus 2 minus 3 minus 2. Okay, the first thing you should do, we have one matrix, let me call A matrix, and we have another matrix, let me call B matrix. Not necessarily the same dimension, but important checking see matching perfectly with the dimension. This matrix is 2 by 3, 2 row, 3 column. However, the second no, the second is 3 by 3, it's a square, 3 row, 3 column. This number matching perfectly with this is different, entonces the answer is impossible, professor, the multiplication. But in this case, yes, matching perfectly, and the answer is another matrix is 2 by 3. Where come from 2? This 2 is this 2, and this 3 is this 3. So 2 by 3 is 6. We need to find 1, 2, 3, 4, 5, and 6 numbers. We can do by hand, but that's too long. Hello. I prefer doing in the algebra. Let me try. Okay. Let me try to share the screen. Do you see your algebra?
Yes.
Yeah. Let me erase everything. New example, totally different. Boom. Hey, just copy the matrix in any place of the spreadsheet. It's 3, 6, -8, enter, -9, 4, and -2. Okay, done. I copy the second. The second, the 3 by 3 contain 9 elements. 3 times 3 is 9. Minus 8 positive. -6. -3 again. Wow. 7. -2 again. -3. Wow, too many negative. It's the long part. The rest is pretty easy. You select the matrix, you create the mathematical object is called a matrix. If you want rename or not, doesn't matter. This is the matrix I call A. Of the matrix capital A. Okay, and capital B. So I select, right click in the mouse, expand this pop menu. And the pop menu you have different things like a copy paste, cut, delete object, in this case create matrix. Okay, and the rename it B. Rename it B. Okay, cool. Okay, so see, I go to the gas. In the gas, I perform the multiplication. A times B. A, capital A, time, que time is shift 8 on the keyboard, period, B, capital B. Multiplication. Bam. And the answer is -11, 90, -14, 19 positive, and -38, que obviously, 50, que obviously is a matrix 2 by 3, o sea, 2 row, 3 column. And it's my beautiful final answer. However, let me try to do in different order. Let me try to do B times A, but curiosity. B times A. Bang. Press enter. Question mark. Because it's impossible. It's impossible because doesn't matching the dimensions. Remember, to match in the dimension, we need the number of columns. And the first matrix would be equal the number of rows in the second matrix. In this case, I flip it up. No, because 3 and 2 not matching. So there's a reason. Entonces, GeoGebra put a question mark. I don't know why, but I know I need to know the concept behind this. Okay, that's the answer. Let me come back to the whiteboard. The answer is okay. The answer is no, that's 0 of boxes. The answer is -11, 90, -14, 90, -38, and 50. Okay, by the way, it's the option C in the handout. Super clear or no?
Yes.
Okay, 20. 20 is super easy, it's the same, a repetition the same. I don't want to repeat, but the conceptual part is the only thing I want. You have two matrices, 5, 7, 2, 3, -2, -8, -9, +9, and 7. And this is 7, negative 5 again, 3, 4, minus 3, 8, minus 3, and 2. You see clear que that matrix is square, 3 by 3, divided by 3. My question is possible doing the multiplication? Yes or no? It's possible or impossible?
Possible.
Possible, because that number matching perfectly with this. And the matrix you obtain after the multiplication would be, what is the dimension of the new matrix?
The same 3 by 3.
The same 3 by 3. I did, guys. And the answer is 72 minus 3 minus 42. You do 1 by 5 by yourself, but not now. 1 minus 25, 20, 60, and 32. Bam! Take the option B in the handout. One more. 21. 21 is multiplication dot matrix. It is 2, negative 8, 1, 6, 0, 1. Time, multiplication, period. Minus 3, 2, 1, negative 1, 6, 1. Okay, so I can see the multiplication here, period, period. Is the dimension for the first matrix 3 by 2. 3 row, 2 column. And the second is the same, 3 by 2. What do you think? Matching the dimension to perform the multiplication? Yes or no?
No.
No. Therefore, the answer is not defined. Not ready to perform the multiplication. Everyone understand very well, guys? 2021. 22. Well, let's do it now in inverse method. Let me recall the idea. Suppose that I have 4, so let's do it in any possibility. Doing by hand, doing the software GeoGebra, verification, and see we are doing well. The first example, the other example is not necessarily repetition, no, it's similar. Entonces now, suppose that one matrix is given 4, negative 1, 5, and positive 1. I call, for example, matrix A. By the way, this is 2 by 2. 2 row, 2 column, square. Yeah, I need to compute the inverse matrix. Inverse. This is the notation. Inverse matrix can look like exponent negative 1, but actually it's not negative 1, it's inverse. So it's not 1 over A because the division of the matrix is impossible definition of that. No define the division. It's inverse. But it's, it's very, very equivalent. Okay, so now you need to remember this formula. Suppose the matrix 2 by 2 is super easy. A, B, C, D. And the inverse of the one matrix like that is 1 over the determinant of A. I want to compute it now. And the most important that you have to remember is that you interchange A and D. So you put D here and A here. Interchange. And B and C, no. Stay the same, but the opposite side. And what is the determinant of A? Well, this is the formula specific for 2 by 2. Si es 3 by 3, no. So now, determinant is easy. This is my determinant A, B, C, D. You multiply A and D, no change the sign, A times D, minus B and C. So the formula is then Bueno, 1 over AD minus BC. And inside the determinant is D minus B minus C. Entonces you say, wow, it's weird, Professor. I know it's weird. But this is a scalar. Entonces remember the multiplication for the one matrix for the scalar. You multiply one by one. It's different to the determinant. So actually, the big inverse matrix would be D over AD minus BC. So you divide this, divide by one, here, 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 and here. Minus B, AD minus BC, minus C, AD minus BC. Of course, we are doing numerical, no literal equation. And A over AD minus BC. Okay, let's do it specifically in our example. This is the formula, but it's easy. Okay, my recommendation is doing first the determinant. Step one is compute the determinant. Oh, easy. Multiplication this and this. No change the sign. Multiplication this and this. Yes, of course change the sign. So 4 plus 5, no? Because 5 times negative 1 is negative 5, but you change the sign, and 9. Okay, so this determinant value is 9. Actually, I need to divide it by 9. So in the formula, in our specific example, we have 9 here, 1 over 9. And the rest is pretty easy. The rest is you interchange, you put 1 over 9, you put 1 here, 4 here, you permutation this and this, swap, and this is 1, pero positive, and negative 5. Okay, well, you can write like that. Yeah, you can. Or much better, this answer correct. So you want to condense in only one bracket, this is 1 over 9, 1 over 9 again, negative 5 over 9, and positive 4 over 9. Bam! And this is the option B and the other. You understand?
So you will replace the 4 and the negative 1 with 1?
Say again?
So you would replace the 4 with 1?
In what part?
The
Determinant.
yes.
No. Determinant is the classical. Okay, we see before. You multiply this and this, 4 times 1, and this diagonal, when you navigate for this diagonal, no change the sign. And when you multiply this and this, you have extra negative 1. Negative and negative together become positive. So you compare the determinant, 2 by 2, exactly the same we are doing before. Maybe your question is, in the permutation of the number inside, no? Well, that's easy. You swap 4 and 1 with the same sign. You swap 4 and 1. You put a 1 here and the 4 here. But 5 positive and negative 1, no. Stay in the same position, but you change the sign, plus minus. Bam. And divided by determinant, boom. We computed the inverse matrix. Cool, mister?
Yes.
But no, I want to make sure. Well, one possibility is, let me go to the algebra and I try to find the inverse matrix. Okay, let me try one more time. Okay, switching to the algebra. Do you see the algebra? You see?
Yeah, we see it.
Okay, cool. Now I delete. Delete maybe is press delete in my keyboard. Wait. I select everything. Delete. Done. I copy my elementary matrix at the beginning. It's 4, negative 1. 4, negative 1. Enter. 5. And 1. Eso. Now I select, I convert to the matrix object. I have here, you want rename or not? Let's rename. This is not mandatory, you know. It's capital A, make. I go to the gas as I put the keyword invert. Invert. No inverse, invert. I don't know why invert. Invert matrix A. And you see 1/9, 1/9, -5/9, and 4/9. This is the invert matrix. If you want to verification, everything is okay. Well, we do by hand, with verification here, but just in case, I want to make sure we multiply A, get the original is given, multiplication, time, invert of A. Bam, and you get the identity values. So, on those each other. Okay, it's similar to the when you are doing the multiplication, one number is reciprocal. Of course, this is speaking in the one dimension. Now it's in 2 dimension or in 3 dimension. Pero es similar idea. O sea, when you multiply 2 times 1/2, the answer is 1. So when you multiply one matrix times its inverse, the answer is identity matrix in the same dimension or the dimension of the original matrix. Cool? Everyone follow me?
Yeah.
Cool. Okay, so now 23, I suppose que es similar. 24, 25 is the same idea. The only difference is que change the dimension. I suppose que you can practice. Because I want to spend the time that we have in the most complicated case. Not complicated, pero es solution for the system, pero using inverse matrix. So you consider que es not necessary doing 23, 24, and 25 because it's the same thing. It doesn't matter que es 2x2 or 3x3. It's the same thing. You put invert of the name of the matrix you have in GeoGebra. Of course, the rule is any problem 2x2, you are doing by hand. Any problem 3x3, no by hand, doing using GeoGebra, right? So I propose you, I don't know, skip that and go to the 26. Are you agree or disagree?
Agreed.
Okay, so let's do it 26. And see, we have time, we're doing 27. I guess very, very similar to 26. X plus 2y plus 3z equals 4, equation 1. X plus y plus z equal -5, equation 2, and x minus 2z equal -6. Yeah, that's -6. Equation 3. This is the system is given, but you can using reduce row echelon. You can use a grammar rule, but in this case, no. In this case, they want that you are using inverse matrix formula. Inverse matrix formula. And what is the inverse matrix formula? Let me recall. The inverse matrix formula is capital X, que es a vector formed by the unknown x, y, z. In this example, we have 3 by 1. S equal to the matrix A, que es 3 by 3, que es the matrix in front, so the number in front so the coefficient from the variable, and the vector b. Okay, the vector b is the vector 3 by 1, que is the right hand side, but here inverse. This is the formula. So the formula is x is equal inverse matrix A times B. So we have A matrix is a matrix formed by coefficients is square 1, 2, 3, 1, 1, 1, 1, 0, negative 2. This is the matrix of. This is the matrix 3 by 3 square. If the determinant is not 0, entonces es invertible. Pero you don't know. You try and you see the inverted exists is because two conditions. It's square and also it's non-singular. And non-singular means that the determinant is non-singular. And the matrix B is matrix B is 4, negative 5, and negative 6. Okay, is the matrix 3 by 1. When you apply the formula, you have to you copy this A matrix. You perform the inverse matrix of this, of course using GeoGebra, and multiplication B, que es 4, minus 5, and minus 6. When you perform this multiplication, it's 3 by 3 and 3 by 1, for sure matching perfect the dimension. And you get a new matrix que es 3 by 1. This 3 is this 3, and this 1 is this 1. And this is X, Y, and Z. So you get, it's magic. When you multiply 3 by 3, get 9 numbers, times 3 by 1, get 3 numbers, you obtain 3 numbers, like a column vector. And this first component is X, second component is Y, and third component is Z. Let's do it. Okay. Do you see GeoGebra?
Yes.
Okay. Let me delete everything because we start new example. I copy A. A is 1, 2, 3, 1, 1, 1, 3, 1, 1, 1, 1. Negative 1, positive 1. No, mistake. Mistake is negative 1, 0, because Y is missing in the third equation. Minus 2. Move. This is my matrix A. But remember, in the formula, I need the inverse of this. Oh no, this is after. Hey, what is the noise? Entonces I copy in one part, I don't know here, maybe. The right hand side get 4. Negative 5. And negative 6. Okay, ready. And you convert this array of number like a mathematical object, it's a matrix. Okay, I rename with the specific name in our example. Matrix A. Okay. Now likewise, I select the column vector this, que is only one column, 3 rows, and again I apply the creation matrix. AI call B. Rename B. Now I have everything ready to perform the computation. The computation is invert 8, invert I-N-V-E-R-T. Invert who? Invert 8. Multiplication. I click on this. Yeah, this is the inverse. Wow, it's crazy. But I put the period, the multiplication who? Multiplication B. Yeah, I press enter now. Bang! Something, I know something is wrong. Let me double check in my computation. 1, 2, 3, 1, 1, 1. I make a mistake here. This is 1, no negative 1. The beauty is that if you change, everything changes. Bang! 1, 0, minus 2. And the solution is the vector minus 22, positive 25, and minus 8. So what is the final answer? The final answer is x is equal to minus 22, y is equal to positive 25, and c is equal to minus 8. Cool?
Cool.
Eso. No problema. And 27 is the same stupid thing, guys. You have to practice. I don't know if you want to do for you or not, or we finish. What do you think? We are doing 27 or no? Or is the same stupid?
No, it's the same. I think we're good, Professor.
But I want to hear everyone. See, one student wants, I do that. How do you feel? I have a question. How do you feel in the manipulation GeoGebra? You are doing, but you try before today doing by yourself or no?
It's manageable.
Okay. Okay, this is my final answer, guys. And this 26 question was, look, I compute that part equal. Okay, what's the multiplication this and this? I doing using GeoGebra. I obtain minus 22, positive 25, and minus 8. Therefore, conclusion, x is equal minus 22, y is equal positive 25, and c is equal minus 8. Or another way to write this idea is minus 22, 25, the triple order minus 8. Final answer que corresponde with the option C in the handout. How do you feel for the test? To get 100 points? Remember, guys.
You ready?
Yeah. Remember, any question about the homework with enough time, you email me, make a screenshot the problem of the you want a help, no? No the test. By the way, I realize the question that you send me is the homework or the test because it's different color. The test is another color different to. So I understand que no. Entonces, I cannot help the test. The test is it's up to you, no? Not for me. I passed this class, right? The homework, yes, because you are studying. You are doing just how you study, doing the homework, watching. Entonces now, I want to. Now, when I create the video for this lecture, I as always, I send to you, but I send also another video, or no one video, you know, a playlist of the video with the solution of the review package, but in detail. So in detail, using no, in this moment, I never using GeoGebra. GeoGebra is relatively new. In this moment is 2013 something. We're using the the graphic calculator, no? TI 89 or 83 or 84. It's similar idea. Entonces, I want to send two videos. That video for today and another video for today. Okay, cool. No problem.
Okay.
Okay.
Yep.
So now, good luck. I wish. Bye-bye.
Bye, Professor. Thank you.
Mm-hmm.